I'd like to go over an example from the book using the continuity equation. So this is the example 1311 from the third edition of Knight's book. And what the problem is, it says that, let's say you have a blood vessel, and this blood vessel we can then try to approximate as a cylinder. So this cylinder has a diameter of 6 millimeters, and it has a length, I'm sorry, 6 micrometers, sorry, and it has a length of 1 millimeter. So there's 1 millimeter to this this blood vessel. And so what we want to find out is two questions. One, what are the number of capillaries or blood vessels that we're trying to analyze here? And B, what is the total surface area of all of our capillaries? Total surface area of the capillaries. So basically the idea is that, say we have a blood vessel, and then that blood vessel branches off into all of these capillaries, and then the capillaries now have basically they're 1 millimeter long and they're 6 micrometers in diameter. And so we want to find out how many there are in the body. So instead of having to actually dissect someone and then sit there with a microscope and count them one at a time, let's use physics. And so the other information that we have is that the total flow rate, the total flow, basically the change in the volume with respect to time of the blood through all of the capillaries is 5 liters per minute. Okay, so now we'd like to use our meters, kilograms, seconds units, not liters. So we have to change the volume from liters into meters cubed. And so there is 1 meter cubed for every 1,000 liters. And there is 60 seconds in a minute. So we can cancel out the units, and we get a flow rate of 8 times 10 to the minus 5 cubic meters per second. So that's the amount of the volume of blood flowing through all of these capillaries that we have. Okay, so let's do with the velocity. So the velocity is basically going to be the length divided by the time. And so we're looking at the amount of blood that's flowing in a second. And so the length in one capillary is 1 millimeter for 1 second, or 10 to the minus 3 meters per second. So that's how fast the blood is going to be flowing through these capillaries. Okay, so well, if we have the flow rate and the volume, we can calculate the area. So the area is the flow rate is the area times the velocity. So the area in total is Q divided by V, which is 8 times 10 to the minus 5 meters cubed per second, or divided by 10 to the minus 3 meters per second. So what we get is a total area for all of the capillaries of 8 times 10 to the minus 2 meters squared, or 0.08 meters squared. So that's the total area of all the capillaries added together inside this system. Now the area for a capillary is pi times the radius squared. So that's our capillary. So therefore, to get the total number of capillaries, so part A, we just take the total area and divide it by the area of a single capillary. So we would have 0.08 meters squared divided by pi times the radius. We said the diameter of a capillary is 6 micrometers. So that means the radius is 3 times 10 to the minus 6, and we have to square it. So therefore, the number of capillaries turns out to be 3 times 10 to the 9 capillaries. So it's a much easier determination than having to sit and dissect something and then sit under the microscope and count basically 3 billion capillaries, which could, take a long time, especially if you're using, unpaid undergraduate volunteers. Okay, so now what we want to do is we find what is the total surface area of all of these capillaries. So now if you take all those capillaries and you were to basically, again, think of them as a cylinder. If you were to now slice this cylinder and open it up, what you would have is a rectangle which has a length L and the other side a width of 2 pi times the radius of the capillary. Okay, so the surface area of a capillary is 2 pi times the radius times the length, which we can calculate for a single capillary as 2 pi 3 times 10 to the minus 6 times the length of 1 millimeter. So that comes out to 2 times 10 to the minus 8 meters squared. So that's the area of a single capillary. To find the area, the total surface area of all capillaries together, then that would be all the capillaries, the number of capillaries, times this surface area of a single capillary, which is 3 billion capillaries, times 2 times 10 to the minus 8 meters squared for a single capillary, which turns out to be 6 times 10 to the 1 meters squared, or 60 meters squared. So that's pretty good. 60 meters squared, you're thinking that, a meter squared is approximately 3 feet by 3 feet. So you're talking like 9 feet squared. And so you're talking somewhere around 540 feet squared. Or another way, if you want to think about it, 1 meter is approximately 1 yard. And so football field is 10 yards wide. And so you basically have to go about 6 yards. So it's running all those small capillaries inside the body. But if you take them out one at a time and unwrap them and stack them all up, it's going to cover a pretty large surface area. And the more interesting thing is we did this whole calculation not having to actually dissect anybody, but just using our equation for continuity, that the flow rate is equal to the area times the velocity. So if you can measure the velocity and you can measure the area of one, if you can measure the flow rate and you can measure the velocity, then you can get the total area and figure out how many capillaries there are inside the system, which is much less evasive than having to take apart a whole human being.